right.
Hey, everybody. I think we're having a slight issue with streaming to Twitch right now. I'm not sure. Is it? Are we on Twitch, Brett?
I'm going to work on that. So
Okay.
let's see what I can do. This is cool.
Okay.
In
so
fact,
Brett
I'll
is
be right back.
Okay. So right now, I think we're just on Periscope and YouTube. I think we will be live on Twitch hopefully in just a moment here. But in the meantime, while we wait for Brent to do that, Paavan, let's just chat because we have a few viewers watching us until the Twitch viewers come in. So Paavan, I look at you as our resident security expert. You're kind of the go-to for all things security with containers. And today we're going to talk about Fargate. We're going to talk about the platform version 1.4, and then some of the security features that came with it. Maybe you want to talk a little bit about some of the things we're going to go into today.
Yeah, sure. So good to be back, Adam and Brent. I think it's great that we're doing these shows and we're getting feedback from our viewers, and we have some dedicated viewers like W. Shari. Do we have him? I think he's around. I saw him in the previous stream, so that's great. Thanks for joining, everyone. So yeah, having been in and around AWS security for more than 5 years, I think in terms of what interests me now is our container services and how we are sort of enabling customers using various features which we already have, like KMS and CloudWatch and a number of other features within security. What I got really interested in was really low-level stuff and the innovations that we are doing around Firecracker and Bottle Rocket, for example, and also like how we are managing the kernel. So with Firecracker, we have a separate kernel for each it's called a micro VM, but it enables our customers to isolate their workloads in a dedicated kernel. So that's very interesting. And then in terms of Fargate, what we have done so far is also interesting, where in April, something we were kind of really pumped on in April, it seems, because for Fargate teams, the team announced a bunch of features on a single day. So if you look at, we'll go through it, but if you look at the blog posts in April, we saw a number of very interesting next level kind of features which allowed customers to improve their experience on Fargate. So that's been really good. We've got some really good feedback from customers who are using Fargate, and they have some challenges as well, which we tried to solve this with this announcement. So one of the announcements was around enabling this particular capability, which is called CAP. It's a capability called sys-PTRACE, so sys_PTRACE, and that is related to security in terms of how it enables customers to meet their not just security requirements, but also compliance requirements as well. So I'm very excited to sort of look into this. We have a partner, Sysdig, who is really sort of active in this space. They have done a lot of open source projects like Falco and PDig and of course Sysdig. Their tool chain is really strong here. So we're going to use some of their tools to understand the feature which we announced.
Yeah, and I just really quick, I do want to go back and talk about some of those Fargate platform version 1.4 releases. Mm-hmm. And yes, before that though, yes, we are having some problems streaming to Twitch right now. So our normal Twitch stream is having some issues, but our good friend who watches the show is calling us out here. So we're working on it. It's I don't know. We got an internal problem working with Twitch. We're working on it though. It's all the behind the scenes details. I don't want to bore you with that. But I did want to also mention that you can watch us on YouTube. So Brent had posted it in our chat. And hey, Brent, welcome back.
Hey,
Hey, Brent.
I'm still working on it, but for now, you can definitely watch us on YouTube and
Periscope on Twitter.
Yeah, Twitter and YouTube both.
So, but as we're working through that, so some of the things, and I'm going to share this blog in the chat, but Paavan, you had mentioned that like we kind of went a little nuts with all the stuff we released in April with platform version 1.4 for Fargate. EFS was one of those, right? So we added EFS support to Fargate tasks, and this was with platform version 1.4. As a larger volume, right? A larger ephemeral volume for your container. What else? I can keep going.
Yeah, so we had a bunch of announcements. EFS, so Fargate supported EFS endpoints, supports it now. We have now a consolidated 20 gig ephemeral volume. And now, like after a few weeks of that announcement, we announced server-side encryption using KMS. So customers get the volume encrypted. That ephemeral volume is encrypted using KMS keys, which are managed by AWS, so the customers don't do anything. So as long as they're using platform version 1.4, which by the way is not the latest version. So if you tag the latest, then it's 1.3. So that's a little bit of confusion for customers, but we are trying to make sure these releases go in sync. So that's one of the reasons of that peculiar naming. But for PV 1.4, when you sort of use that for your task definitions and tasks, your data will be sort of automatically encrypted at rest using server-side encryption and KMS.
Yeah, so basically, that's a really nice feature. And I know a lot of customers were asking about that just for compliance requirements, different reasons they needed that volume to be encrypted. And so just to talk about that point of latest versus 1.4. So in your task definition, when you define what platform version you want to use for your task, if you point to latest will point to version 1.3, not 1.4. But soon enough in the near future, latest will point to 1.4. So, so what do you think about talking about PTRACE? Should we get into it and see what we can do?
Yeah, sure. So we can take a look right now. So before we do that, let me share my screen. So here's the announcement. So we had a bunch of blogs written on this as well. So our colleague Massimo wrote a great blog around this announcement. So what's new in Fargate 1.4, EFS that we just talked about, 20 gig ephemeral volume. ENI runs additional traffic flows. So improvements on our ENI. There you go, some details there. And then performance metrics are available in CloudWatch Container Insights. So so yeah, I think I'm just looking at some of the comments, but there's some confusion around the streams on Twitch. So I think we'll sort it out.
Yeah. Again, apologies, folks. We're working through some technical difficulties, but the show must go on. So we are continuing here. Anyway, sorry to interrupt you, Paavan.
Yeah, no worries. So this is the one that caught my eye in terms of security. So in 2017, we introduced support for adding Linux capability to ECS tasks, and Fargate is peculiar in terms of how it offers customers, it takes away the heavy lifting from customers to manage EC2 instances. So let me jump into an experiment here. Let's see how it works. Adam, I think when you're on vacation, we tried this and we had some issues, but yeah, we'll try and have a go at this again. So I'm using Sidecar, which is a Mac OS function, and And yeah, this helps me visualize my concepts, like draw things across. And can you see it on the screen?
Yeah, so it's
Yeah,
looking good so
cool.
far. And just sorry to interrupt again. People are asking, should we go back to Twitch? Just for now, I think let's stay on YouTube. If you want to watch us, stay on YouTube, or watch us on Twitter.
Okay.
Anyways, go on.
Yeah, great. Just real quick, I mean, in terms of PTRACE, I wanted to use an example around PTRACE, as in make it a bit more useful context for people. And I know we've had Justin on the show who's using props, so that inspired me as well to kind of use props and make some analogies. And this is mine. So if any of the viewers kind of recognize this, they can let us know in the chat what this is. And it's kind of my parallel for what PTRACE is for Fargate. So this is a tool that you'd use where it helps you see a few things that you don't have access to. So this is, if anyone has a view on what this is, they can put down their comments in the chat and then let us know. But yeah, it's a little quiz for you, and we'll give you about 30 seconds to search in Google, use your ML algorithms or whatever you want on the stream, and get us the answer.
Nice.
Great. So great. I think we are getting
chat's a little slow right now.
Yeah.
I think. Waleed.
Oh, we've got Waleed. Yes, that's the one. Yes, car issues. Excellent. Yeah, you get it right always, Waleed. So thanks. Great. So it is indeed an OBD2 scanner. So that is every car nowadays. I mean, even 15 years ago, the cars have this port somewhere hidden between, like underneath the driver's seat, so as the steering wheel actually. And what this does is provides you insights into what's going on within your engines, so electronics, and all the metadata which is going on within your car. So if you have a engine light on or something, then you can determine what kind of P code is running, what kind of code is there, and search for the code and find out what part of the car is having issues, and then address it. So I was thinking about how can I make a parallel for PTRACE, and Fargate is kind of similar in terms of it's a car or an engine that's given to you with no ability to open the hood. Like you don't have much capacity to sort of look at what's under the hood, what kind of things are running. With an EC2 instance, it's a different thing where you own the instance. So if you're running ECS with EC2, then you own the instances and you'd manage them as well. So let me bring up the screen now. That would help you understand it better. So within okay, right. So we have ECS and EKS both on Fargate, and both have two options in terms of running your workloads or containers in. So one is using your EC2 nodes or instances, and that would run as a cluster of nodes with your to run your containers. And then you have Fargate, which is our managed service, where you don't have to worry about running the nodes. You don't have to worry about patching them or maintaining them. It just works when you provide your task definition and you want to run your task. So what do you want to run? We'll run it for you. Now the problem with this is that you don't know what's running under the hood. As in, sometimes as customers, like you have apps which are under security requirements or compliance requirements, which are coming from your organization, or you have regulatory requirements which are external. So one of the good examples is PCI DSS. If you're running an app, and that's the case for several of our customers where they are running or developing applications which are running on Fargate, and they are financial services application dealing with payment card data. So if they are doing that, then they have to comply against PCI DSS. And PCI has a few requirements which says run host-based intrusion detection systems or run file integrity monitoring systems. So when our customers come across so HIDS is host-based intrusion detection systems and file integrity monitoring systems. So host-based intrusion detection, the name kind of is self-explanatory, where you have a module or some kind of agent running or a service running which helps you detect any intrusions at the host level. You may have heard of network intrusion detection systems, which are running at a network level, but then you have host-based intrusion detection systems as well, which is kind of mandated by PCI, and then for your cardholder data environment. And then FIM is file integrity monitoring systems. If any of the sensitive files or system files change, which is kind of the case when you are a malicious user kind of attacks and changes your configuration, when there is a virus or any system-based software which is trying to intrude or attack, then they would go and change those files. And that's why file integrity monitoring systems are important.
And so, Paavan, and so I wonder, in the case of, maybe you can help me understand. So I see the two scenarios where we can run our containers on EC2 versus Fargate. Now, obviously, Fargate, as you said, as we know, is basically, it's a black box when it comes to the host. It's managed by AWS. So me as the customer, I'm not worried about patching it, maintaining it. So I guess in the two scenarios, why would I need to, and you mentioned compliance, but why would I still need to have this capability to have file integrity monitoring, host-based intrusion detection from the Fargate perspective? Could you maybe elaborate on that?
Yeah, so the reason being, our customers want to have the benefits of Fargate. Fargate provides clear benefits in terms of how, obviously on the security of the cloud piece, where AWS is responsible for managing compliance of Fargate and security of Fargate. You are receiving highly scalable service with all the bells and whistles around security and compliance, to not worry about it. So here's the difference. When you are complying with PCI DSS, for example, for managed EC2 nodes, you have to demonstrate logging capacity for 12 months, like you're keeping logs from your nodes, you're keeping the systems up and running, you have the patches applied to your OS and any other applications that you're running on top of it, and you're managing the OS layer heavy lifting and the upkeep and the uptime as well. So all these non-differentiated heavy lifting is eliminated by Fargate. Our customers recognize this, and that's why Fargate is so popular, that because of these obvious advantages, they want to run Fargate. They want to run sensitive workloads on Fargate that require PCI compliance. So and Fargate provides HIPAA compliance, PCI compliance, and all the other compliance standards, which removes that heavy lifting from our customers' side, and all they have to worry about is demonstrate compliance measures against their task definitions or tasks, and it removes a lot of the friction from what they are trying to build.
Nice. Awesome. Thanks for that.
So in terms of the OBD2, is a parallel around this Fargate box, which is there, and you have this OBD2 which you attach to the car, and in the same way you have PTRACE attached to your Fargate container. And we'll do that and show you how that works. And that's the reason for this the show is, okay, how can I attach this to my container? Because we didn't go into enough details back then, and so this is a show which allows you to do that. Now, let me. I think the next thing I would like to do is to talk about what is PTRACE, as in why is it important, and what's the reason for enabling this. So within Linux and the kernel, there is a concept around capabilities, and if you are into sort of deep level kernel sort of reviews and understand, like if you understand the kernel and containers even, then you might have come across this capabilities concept. So capabilities are a thread level per thread attribute, which allows so starting with kernel 2.2, they for privileged processes. So there are two types of processes running on your kernel. One is privileged and the other is non-privileged. And when you are running a privileged process, like you are root and you're running a task, then each process is attached capability, and that capability defines what you're allowed to, what the processes are allowed to do within the kernel. So what hardware it's able to access and what kind of activities can it do. So there are about 40 capabilities which are there in a kernel, depending on your operating system. And by default, we'll see how many are enabled within Docker. So Docker took a view into this because if you don't realize, Docker needs kind of root permission, so it runs as a privileged process, and that's how it creates your containers. So when you install Docker on your laptop or wherever, if you look at the processes and the privileges that Docker is running with, it runs as root basically. So it needs that level of privilege to do what it's doing for containers. Now that's pretty serious, and that's why we have capabilities which allow us to limit what the processes are allowed to do. So here, let's take a look real quick around a demo and see what. Hold on a second.
Cool. We have your terminal, so just so you know,
great.
It's looking good.
Great. So I'm going to run simple sort of Debian instance here, right? And I have a shell within the Debian container, and what I'm going to do is use this command which allows us to print all the capabilities which are attached to this process. Obviously, a container is a process, and then you have these capabilities attached to them. If you count them and have a look at them closely, you'll see 14 capabilities there. So by default, Docker has decided that to run containers, that process for your container doesn't need any more than 14 of those capabilities. So that is enough for you to do the jobs that normal containers would require to do. So that's what this is. But then let's say you have a specific kind of application which you need, and it needs some other privileges. So in that case, you would kind of use this flag which adds the capabilities, and in this case we'll just use trace. So now that I have a shell with this container, we'll take a look at it again and see what capabilities this container is running with. Again, we have the list of capabilities, but interestingly, we have the capsys ptrace capability. So what that means is this container can use that capability when it's running with all the threads that it's running. So remember capabilities are a per thread attribute, so they are attached to a thread in the process. So that's how this works. So that's a quick overview around capabilities. And now one of the other things you'd come across is with something like PTRACE, which allows tracing of processes. P stands for process. It traces process, and it's really heavy in terms of what it does in terms of the resources it has and the privileges it has. So compared to PTRACE, there are other tools out there you might have used, which is strace and also dtrace and some of the others, which allow you to do some really different things. It can be considered as a hammer if you're comparing with strace. Strace is more specific, and it allows to sort of manage your syscalls and view it and whatnot. So there's differences, but this is the capability that we have enabled, which allows partners like Sysdig to enable tracing and looking at the processes in a bit more
Paavan,
detail.
do you think so? Enabling CAPSys PTRACE, is this something that, if I'm just coming into containers today, I don't have PCI compliance requirements, I don't have some of these other third-party requirements, should I be enabling sys PTRACE by default? And I guess why would I and why wouldn't I?
Great. So that's a great question. So so in terms of should you be enabling this? It's not as easy as clicking a button. So you have to make a conscious decision, and we'll take a look at it soon around how we do that. But you have to include it within your task definition. You have to include it within your container definition that this is what you want to enable. So it's not as easy as clicking a button on the console or CLI. And as Waleed mentions, this capability can be risky, as in it comes with its kind of privilege escalations, and that's understandable. But if our customers want that level of access in terms of tracing capabilities, yes, you can read what's happening. It's just, again, the reason for using this analogy is that using this OBD2 scanner, you can read through what's happening within your engine or your car, and that's what PTRACE allows you to do as well. So trace your processes and understand what's happening. We'll take a look at the other way you can protect what's going on in terms of your container, and that's through syscalls and another feature within Linux called Seccomp. So let's jump into that and really quickly look at Seccomp. So here we have created a Seccomp filter file, a JSON, which shows us the default actions I would allow, as in all the actions are allowed, but the syscalls which I've listed here are denied. So basically that's the policy which I'm putting in the filter. And then when you run it with Docker, so if I'm doing docker run rm, let's stick to this. But again, with this, I'm using security options, Seccomp, and with that, I'm specifying this filter, which is Seccomp underscore. This is the file. So here I have the container running again, and it has the ptrace capability. But now what I've done, interestingly, is restrict a few syscalls. So make dir. So if I'm trying to make a directory within this container, not permitted because I've blocked the syscall. If I'm trying to change the ownership of my file, let's say shown. Let's say just.
There's no. Oh, there you go. Good old shell.
Okay. Yeah, what I was hoping was it wouldn't allow me to use.
Would that be the case even if you are the user? It's just disabling those calls altogether, right?
That's right. Yes. Yeah. So it disables the calls altogether. Let me take a quick look around this.
And this is why we love containers from the couch, because we do it live, and sometimes we run into issues and we try to work through them. But so just to recap so far, so you've enabled PTRACE functionality, as you're kind of working through this. And the next step is you, with PTRACE enabled, you also using Seccomp, you've filtered out some syscalls that you want to say, hey, we cannot make these syscalls when we're in the container.
That's right. Yeah. So depending on your application, it's again going back to the least privilege concept within security. So we don't want to allow processes, software, or services to have more rights than they do. And that's the concept behind a number of our projects. Like if you look at Nitro or even S2N or some of the security initiatives that we have put forward, you don't, if you don't need those services, you don't want to enable them. And that's what Docker has done as well. So Docker has enabled about only a handful of syscalls and 44 syscalls, I think, and 14 capabilities. There are about 300 plus syscalls altogether, but Docker said these are the number of syscalls that we need, or the normal user needs, and that's what we are going to use. So yeah, depending on your need to know and your access requirements, that's what you'd enable.
Cool.
Okay. So here again, I've ran this Seccomp policy around filtering make directory, and it's not allowing me to make directory. And then for chown, I'm trying to do the
something with the shell.
Okay, that's okay. I think that is because I have the sys-ptrace enabled. Let me see, that should be the interesting one. If I'm
But yeah, like so chown should work. Still worked. Okay.
Okay, that's interesting. Hoping it wouldn't allow me to do that, but again, let me try with Alpine. Shouldn't make a difference, but just let me
and maybe start with chown. Yeah.
So with Alpine, it works. Yeah, for some reason it doesn't work with Debian. Is there anything unusual about this?
Yeah, no, can you start with chown here? Yeah.
Yeah.
It seems like something with the shell. Oh, no. Okay, it's not the shell. Anyway.
Yeah. Anyway, that's a good finding. So something interesting that we found out about, it's not related to the capability. Again, it's something to do with the way the container is configured, how it's handling those requests and managing those syscalls. So it's a good thing we need to look into. Yeah, very interesting. So so that's syscalls basically, and that's Seccomp, syscalls, and capabilities. So these are tools within the kernel to enable you to kind of restrict what accesses you can provide to your processes or threads, and restrict, really harden the container. Okay.
And Waleed was asking, what if you had another command as well, just to see? Maybe what I imagine, is this maybe Waleed trying to help us troubleshoot?
Yeah, I think there's a few more interesting things I'd like to show before we. I think we just have 20 minutes. So, Waleed, I give you a challenge to try Chug group and see if it works. It's pretty easy, like Docker containers. So you just run a couple of commands, but it's a good one to test. It doesn't work for Debian for some reason. It works for Alpine, so great. But yeah, let's jump into the actual hands-on part of this, where we actually go ahead and create a cluster and see this working. So I have a Fargate cluster which is running right now, as in which is created, and there's no task definitions within it. So we want to create a new task definition. Okay, so clearly we'll be using Fargate here, and for the task definition name, I'm going to use ECS, PTRACE, Falco server. So here we're using open source tooling called Falco, created by Sysdig. And this is the demo which I sort of changed a bit from Chris Nova's kind of open source contribution. She has put in a repository, which is very useful. So you want to check it out. I have some details around it, which I'll share. But yeah, let me put down the container details.
Cool. So right now you're creating a task definition for ECS with Fargate. Use a task definition. Look at this as like your kind of like your deployment spec or your pod spec.
That's right. So I have this this container sort of hosted in Docker Hub, and just for ease of use purposes, where you can use ECR as well if you want. And this particular container sort of runs on 443, so I'm just mapping the port and has that port open. So and then everything is default, but the log configuration, which is really important, we want to see what logs are pushed out. So so that's great. And then everything else, we don't want app mesh or file lengths here, but the important piece is this, where we have the Fargate container definition here. And then what you do is, within the container definition, to enable cap, so there's a sysptrace, you'd add a block of code around enabling this as a Linux parameter. So what this does is says, add this capability and create that container. So now that we have this JSON, this is how it looks like. And then we hit create. So we have the task definition. And now using this task definition, we just create a service, which is the Fargate launch type. That's really important. And then this is important because the feature is enabled within 1.4 only platform version, which is not the latest. The latest is 1.3, so don't select latest. Just use 1.4.
Not to confuse you.
Yeah. You can just write the service name. I just need one task, and then yeah, rolling updates fine. And then for networking purposes, what I'll be doing is access this container from outside world from my laptop. So it doesn't have any SSH on, but it does have 443. So what I'm doing is enabling sort of 443 connection from my local machine. So for my local machine, the ID.
I think
well,
also
this
in the
is
console you can like just say from my IP, I think in the console too.
all right. Okay. Great. Yeah, that's good to know. Thanks. Thanks, Adam. So now that we have this, we just save it. We have the security group configured, and then we don't want anything else. Next, and that's what we create as in the service. So security group, inbound rules, service has been created. We just take a look at this service and its provisioning, and that's the public IP, right?
Yep, there it is.
Yep. So right now it's pending. It's pulling the image from the registry.
Yeah, and so with Fargate, remember Fargate has it spins up a brand new virtual machine. Your container, your task is isolated on that virtual machine. Nothing else is running on that virtual machine outside of your task that you've set. So keep in mind that's coming up. It's attaching an elastic network interface and so on and so forth. So that's all that's happening behind the scenes right now as we spin up this task.
Right. So one of the things, right, it's running now, so it's great. So it's pulled the image and it's running. So one of the great things I found was look at this blog post by Anirudh. Again, he wrote it the same day of the launch. But what this allows you to do is understand what runs under the hood for Fargate PV 1.4. And it really helps you understand the runtime functionality as well, where we don't use Docker as a runtime. With PV 1.4, it's container D. So take a look at this blog where you look at the previous Fargate setup with Docker Engine. So here, this is the Docker Engine runtime, which creates your containers and manages them. But then with the new version, with PV 1.4, we have updated it to be more efficient using container D. So that's the difference between the two diagrams. That's a key difference. And also the agent has changed. So previously we used ECS agent, but now we're using its own Fargate agent. So all the hosts within the Fargate fleet are using Fargate agent and container D.
Nice.
Okay, so now that we have this container running or service running, we want to attach to it. And this is what Chris did really nice, as in there is a tool which is being used, NCAT or NetCat. And then all you do is, you can do SSH as well, but this simplifies it a bit. And what this did was I'm connected to that container as an attacker. So basically, I'm doing some sort of looking around and making sure I can create some files and directories. So an attacker would probably create some files within sensitive directories. So if you have user bin, I would try and create those, and then I might want to look at the password directory to see what passwords are out there, and I might want to, let's say, yeah, why not touch? Yeah, so something like this on the container, and the reason this feature is important is what we look at now is when we look at the CloudWatch logs for the containers, and for this service, it shows it shows all the activity that I've been doing. So Falco as a as a service which was initialized with this configuration. So it has a YAML, which is the configuration YAML, and it puts out the logs out. And then there are certain rules which are attached. So those are the common rules which the Sysdig team have created. And those are the rules which look at etc directory or user bin directory and the common sort of findings. And then you can have your own sort of local rules attached to it as well. I think it's an empty file, but that's what it is. And you can have this running for your Kubernetes cluster as well. But the interesting thing is you have a visibility of what's happening at the lower levels using PTRACE as a functionality, using eBPF probes, which are used by Sysdig and Falco, and anything that happens on the kernel which you don't want to allow would be sort of appearing as a log, and you have visibility into those actions.
Wow. So this container you're running right now, this is is this just a demo image to kind of expose itself, or talk me through how you're doing all this and how you're able to get in and be intrusive?
Sure. Let's go under the hood now. Let's see what's in here. So again, I have used Chris's GitHub repository for this. So go check it out. I think this is the source. The great work done by Chris here. And what I was doing is really take a look at. I couldn't compile some of the binaries last night, so I've copied them across for the previous version. So Falco basically has Sysdig have a few projects, and one of them is big. So it's a ptrace based event producer, and what it does is really attaches itself to your process and generates sort of ptrace logs. So let me go back to my repository. So here's what it looks like. So this is my base container, and what I'm doing is pulling it from from Ubuntu or Debian, whatever you want, and then installing some of the Falco binaries into this using these directories, the source directories, and then for the server there is init, which. So let's look at the Docker file, which is the server which is running. But essentially, this is the container. So this is the container which is running on Docker Hub, and it installs netcat, ncat, exposes 443, and runs pdig for init. Now, init has, what init does is runs Falco as a daemon, initializes the logs, and these logs are sent out to CloudWatch, as you saw, and then it runs a loop of ncat. So it looks for connections, and that's what we did. So we just connected to that container through this loop, and we were able to run those commands.
So this is just for the sake of the demo.
Correct.
We're doing this to just showcase the functionality. I just want to make sure people don't think, you run a Fargate task and everything's exposed and, oh my goodness.
Absolutely.
No.
Yeah.
This is just
this is just a setup. But again, if you're opening up SSH to the whole wide world, you'd see those attacks coming in, and it's kind of some of the representation around, okay, this happens with our services like Security Hub as well, where some of the definitions that Security Hub runs are kind of assessing those attacks and responding to them, as in you'd have alerts going out for things like sort of mining bitcoins or something like that, and some of those attacks which are running out in the wild. So this allows you, this is a tool chain which allows you to run a sort of deep review through Falco, which is the open source product. And it's layered with services services from Sysdig around compliance and monitoring and sort of visibility as well.
Nice. So Falco is open source, but so you could use it on its own, but it also, I assume, integrates nicely with the Sysdig product as well.
That's right. Yes. I mean, if you look at the website and some of the blogs written on PCI compliance and how Sysdig supports that, they have a great tool chain and feature set which allows you to manage this on scale. So there is probably some other tools out there, but this is the one that leverages our feature set, and they were working closely on this with us.
Cool.
Great. So this allows you to sort of understand what this feature does and how it works under the hood. So as you saw, really to enable this feature, you have to look into your task definition, like create your definition with this flag, as in this JSON, and it's only then this is enabled. So only if you're aware and you want to consciously make this choice is this capability possible. Otherwise, it's running without this capability.
Got it. Yep. So this is like, general, just, least privileged security in AWS. Things generally, access is not enabled by default. This is something that you have to explicitly enable when creating your task.
Yes, that's right. Yes. Waleed's just asked about the user ID. Are you inside the container? Yeah, it is the default container Debian or Ubuntu, so it's running root. Yes.
But I do think it is good to point out and to mention that when you're running in Fargate, this is, again, your task is isolated to that virtual machine. So you're not, essentially, if somehow there was some breakout or something, this is just that one task on that one machine. This is not, you're not running multiple services, multiple tasks on this one virtual machine. It's a one-to-one scenario. So that tenancy is single, by default, and single in nature, just your one task to that one virtual machine.
That's right. It's a dedicated kernel, so it's not shared with any other other kernels.
Yeah. So I think, from a time perspective, we are kind of hitting towards the end of our time slot. Was there anything else you wanted to touch on, Paavan, or maybe recap?
There's more developments coming in Fargate, so watch out for those. And there's features which are really interesting in terms of security. Look at Firecracker. I think we need to do a show around Firecracker as well. Get someone from that team to talk about Firecracker. But yeah, we have some interesting things coming. Obviously, reInvent has been announced, so we'd have some announcement there. I'm looking forward to those. But this is a deep dive into how Fargate sort of manages and enables customers to have visibility and sort of monitoring around their containers, and also enable security and compliance through this. Well, there is another sort of webinar which is coming up, and it's just a quick plug around sort of webinars around ECR. So if you are interested in ECR and using your own keys with ECR repositories, if you want to sort of secure your images at rest, we recently announced ECR integration with KMS. So you can use KMS stored keys or your own keys and protect your ECR images that way. So that is something I sort of wrote about in a blog post we announced a few weeks ago, but then I'm going to do a live sort of tech talk and probably, again, Containers on the Couch show for this and run you through it.
Definitely, yeah. And it's the AWS Tech Talks. We don't have the link right here, but just Google AWS Tech Talks. You'll be able to find that talk and sign up for it, right?
Yeah, Yeah. It's not up yet, but it should be up soon. But I think we are near to closing this. I don't want to step into some other show's shoes or whatever. So let's.
We're okay because of the Twitch stuff.
Right.
But anyway, so I do want to apologize to everyone for our Twitch issues. This is just a miscommunication on our part and scheduling conflict. But we will be back tomorrow, I believe. I think we're still good. No conflicts tomorrow. So we'll be back, Containers from the Couch, with our regular schedule. So please come back and see us tomorrow on Twitch, YouTube, Periscope, and all the things. So
try using